A very good morning to all of you. So today we will discuss and continue our instrumentation series, and one of the important instrument frequently asked in the PG and the examination, that is of your atomic absorption spectroscopy. Okay, so let's start the topic. Atomic absorption spectroscopy. So first of all, a scientist named Alan Watt. Alan Watt. Okay, then Alan Watt was scientist who discovered in the year 1955. In the year 1955, Alan Watt was the scientist who first discovered this atomic absorption spectroscopy. Okay, so this is your first. You will write your introduction. First, you will write your heading is your introduction. Introduction, you will write first point is that of Alan Watt in 1955 discovered this atomic absorption spectroscopy. As the name suggests, atomic absorption. So it is what? It is an what kind of? It is an absorption spectroscopy. Absorption spectroscopy. And being an absorption, as the name suggests, absorption spectroscopy. So it is what kind of a spectroscopy? It is an absorption spectroscopy. And what is the use of this? It is used. Why this technique is used? This technique is used for what? It is used for detection of metals. Okay, it is used for detection of your metals. Okay, so various type of metals that are present in your like blood, serum, urine, in various kind of edible things, in which all these things for detection of metal, what technique you will use? You will use your atomic absorption spectroscopy. Alright. Now it is what? It is both quantitative and qualitative, both. Okay, so as you know it very well, quantitative and qualitative, that means it will tell qualitative, it will tell whether that metal is present in that sample or not. Quality, that is first qualitative, it will tell whether that particular metal is present in that sample or not. So you will detect the qualitative assessment. And quantity is how much. What is that? That means what is the amount of that metal in that particular sample. So you will assess your quantity also. Okay, so it is quantitative as well as your qualitative both. Okay, now comes on the next point is that of, for example, and after that you can write the examples like where you can use it, like you can use it for detection of your calcium, like magnesium, sodium, potassium, ions in what? In your blood serum. Okay, for detection of all these metals you can use atomic absorption spectroscopy, or you can use it detection of like lead. Suppose you want to detect the lead in petrol or gasoline. Okay, so for detection of what amount of lead is present in petrol, or you can write any gasoline, then you will use what? You will use which technique? That is atomic absorption spectroscopy. Alright, so what is that atomic absorption spectroscopy? First in 1955, Alan Watt was scientist who first discovered this technique. And as the name suggests, what kind of spectroscopy is it? It is an absorption kind of spectroscopy. And what is the use? It is used for detection of metal. Various type of metals in various kind of sample you can detect with the help of this atomic absorption spectroscopy technique. And it is both qualitative as well as quantitative. And for like you can, if you want to detect and calcium, magnesium, and whatever ions in your blood serum, like in lead, in gasoline, like you want to detect magnesium in tap water, a lot of examples and lot of applications will there. So we will discuss application later on. Okay, so this is your introduction. Now comes on the principle. On which principle this atomic absorption spectroscopy will work. Okay, as I have just covered the Lambert's-Beer law. While we have just studied the spectrophotometer. So I think you are very well aware of that of Lambert's-Beer law. Okay, so in same Lambert's-Beer law, this technique is also based. Okay, so what is the principle? First you will understand what is the principle. After that I will tell you in theory how you will write that. Okay, first let's understand how this works. Suppose this is your sample. Okay, suppose this is your salt solution. What is this? Is your sample. Okay, and you just heat this sample in any flame. This is your what? This is your flame. Okay, you will put your sample, and sample is what? Sample is your solution, salt solution. Sample is what? It is your salt solution. Okay, and you will heat that sample or salt solution under a flame. Then what will happen first? When you will heat it, then what? If it is a solution, so when you will heat it, first thing what then? Solvent. First thing what is there? Well, while you will heat the salt solution, then first thing is that the solvent which is present in this solution will evaporate. Then solvent evaporate. Isn't it? If there is any solution and if you will heat that solution, then what will happen? First your solvent will evaporate. Okay, so first thing is your solvent will evaporate. After that what is there remaining? Remaining is that of tiny particles of your solute. Tiny particles of solute remains, isn't it? Because your solution contains what? Your solution contains solute as well as solvent, and when you will heat that solution under any flame, then what will happen? Your solvent first, what your solvent will evaporize. It will evaporate. If whole solvent will evaporate, then what will remaining? The only your particles of your tiny particles of solute will remain, and you are going to be continue further heating. Then if you will continue your further heating, then what further happens with these tiny particles? These tiny particles will convert into your gaseous particle. Okay, it will convert into your gaseous particle, and again further on further heating, these your gaseous particle will convert into your atoms. Clear everyone? Till here clear? Let's understand once again what will happen. Suppose this is your sample solution. This is a salt solution or sample in which you want to detect a particular metal. For example, you want to detect here a sodium. Okay, your targeting is that we want to detect whether sodium is present in that salt solution or sample or not. Okay, for that first thing what you will do, first step you will heat that sample or solution. Then while you will heat it under any flame, then what will happen? That solvent will evaporate. If solvent will evaporate, then what will remain? Then only tiny particles of your solute will remain. And on further heating of this solute, what will happen? These solute particles will convert into your gaseous particle, and then again continue heating. Okay, flame is continue, again continue heating is there. Then these gaseous particles will turn into your atoms. Alright, next what happens? Finally, what happened? Finally, your sample is converted into your gaseous atom. Okay. After with heating, finally your sample is converted into your gaseous atom. Then these your atoms, gaseous atom. Suppose these are your gaseous atom, and these are present in your ground state. Ground state means what? Ground state means these are present in your unexcited state. These are not unexcited. These are in unexcited state. Okay. And you are continuously doing the heating. Then these atoms which are present in the ground state, what they will do? They will absorb radiation. Okay. From the flame, they will absorb a radiation at their ground state. And after absorbing this radiation, these will then undergo their excited state. Okay, what happened? First you will take your salt solution, you will heat that, solvent will evaporate, tiny solute particle will remain. These tiny solute particle will convert into your gaseous particle. Then your gaseous particle ultimately convert into your gaseous atom. And on these gaseous atoms, some atoms will be in their ground state. And when they are present in ground state, they want to, by absorbing the particular radiation, they will then transfer from ground state to excited state. And in this atomic absorption spectroscopy, we will deal with this kind of radiation. we will just measure how much radiation is absorbed by these unexcited atoms, and by measuring the amount of radiation we can do the quantitative estimation. How much radiation that particular gaseous atom in unexcited state absorb, and how much radiation it is absorbed is directly proportional to the amount of that salt that is present in your salt solution. So the radiation, so what? So amount of radiation absorbed, amount of radiation absorbed is directly proportional to the what? Amount of targeted metal. So by this we can do the quantitative estimation. Okay, by this you can do the quantitative estimation of that your target metal. Suppose we are just taking the example of sodium, so we will just first detect whether sodium is present or not. So how you will check whether sodium is present or not? Because sodium will absorb a particular radiation only. So if that thing is absorbed that particular wavelength of radiation, then you will sure, okay, now sodium is present. Now if sodium is present, then how much amount of sodium is present in that solution? How you will measure? You will measure that by detecting the amount of radiation. That is how much radiation that particular substance absorbed. The amount of radiation is directly proportional to your amount of target metal. So this is the overall principle of your atomic absorption spectroscopy. Okay, understand it. Now how you will write in your exam? In theoretical point of view, how you will write? You just make this diagram, and after that in flowchart form you can explain it. So what is the principle? So first you will write, first thing what you will do, heated the salt solution under flame. Okay, under flame. So under flame you will heat the salt solution. Then you will heat salt solution. Then what will happen? Then solvent will evaporate. If solvent will evaporate, then what happened next? What remaining is there? There are tiny solute particles remain. Particles will remain. Okay. So and further on, further heating, because the flame is continuing. Okay. So on further heating, these tiny particles convert into your gaseous particle. And finally, this gaseous particle will convert into your gaseous atoms. Gaseous atoms. Okay. So always in your exam try to write in a flowchart form, because flowchart form is easy for the examiner also. He can easily assess your knowledge, and it's also convenient for you to explain all your things in your proper way. Okay, and it will also save your time in your exam. So always try to write in theory exam in a flowchart form. Okay, so first thing, what principle? In first you will make that diagram. After that you will write in theoretical form, like heated the salt solution under flame, and then solvent will evaporate, tiny solid particles remain, and on further heating these tiny solid particles will convert into your gaseous particle, and then finally gaseous atom is there. Okay. Next, what step is there? Next, next is that of your these gaseous atoms. Then few gaseous atoms in what? Few gaseous atoms in unexcited state. Okay, few gaseous atom in unexcited state. Okay, so few gaseous atoms in unexcited state. Then what they will do? They will absorb radiation of particular what? Of radiation of particular wavelength. Okay, and then After that undergoes to the excited state. Undergoes to the excited state. Okay. And this absorption is based on what? This absorption is based on your Lambert's and Beer law. Based on your Beer's Lambert law. Okay, so this is all over your principle of your atomic absorption spectroscopy. Okay, fine. So first you will write your introduction, then you will write your principle. After that you will write application, and then you will write the instrumentation. Okay, so let's understand what is the application of this technique. And in the next video we will understand what is the instrumentation of this atomic absorption spectroscopy. Okay, so what are the applications? What are the applications? So what are the applications? First is used for analysis of various metals. Okay, used for analysis of various metals. In that you will write, for example, first, detection of calcium, sodium, potassium in blood serum. In blood serum. Second, you will detect magnesium in tap water. Suppose you want to detect how much amount of magnesium is present in tap water, or whether magnesium is present in tap water or not, you will use atomic absorption spectroscopy. If you want to detect how much amount of lead in petrol or gasoline, and you want to detect the sodium ions, in edible salt. Okay, how much amount of sodium is present in your edible salt? So for that you will also use atomic absorption spectroscopy. Okay, if you want to detect the selenium in urine sample, for that also you will use atomic absorption spectroscopy. So first application is, it is used for analysis of various metals. For example, you will give all these examples. Okay. First, it is used for the detection of calcium, sodium, potassium, magnesium, various ions in the blood serum. Second, magnesium in the tap water. Lead in petrol or gasoline. You want to detect, suppose you are willing to know how much amount of sodium ions are present in your edible soil. For that you will use atomic absorption spectroscopy. You want to detect the selenium in urine, that is also, for that you will use this technique. Okay. What is the second application? This technique is used in analytical chemistry. Analytical chemistry. You will use it in analytical chemistry. You will use in it mineralogy, where you will detect for variety of minerals. So you will use in analytical chemistry. You will use in mineralogy. You will use in metallurgy. Okay. So these are the applications. Third, you can use it in the food industry also. Use it food industry. Okay. Suppose in any food you want to detect any metal, you are willing to detect any metal, then you will use this atomic absorption spectroscopy. Okay. So these are all your applications. So in today's session, we have just learned introduction. What is atomic absorption spectroscopy? What's its use? What is the principle on which this technique is based? And what are the applications? In the next session, we will understand the instrumentation of this. How this technique is work, and what is the instrumentation of this technique. Okay. So that's all for today. Next we will discuss instrumentation. Thank you.